Hi, my name is Manish Gupta, and in this video, I'm going to talk about unfairness in natural language processing models. And this talk is based on this paper, which is basically one of the ACL 2023 best papers. The first question is, how politically biased are popular pre-trained language models? And here, 14 different language models have been evaluated. The way this evaluation is done is by using a political spectrum matrix. So this chart essentially shows you, of course, there is X and Y axis. So the X axis is economic axis, while the Y axis is social axis. So for economic axis, the way it is plotted is that they consider three different things: left, center, and right. While on the social axis, the spectrum is from liberal to conservative, right? Or libertarian to authoritarian, right? So the way these models have been evaluated is using a test called as political compass test. This test includes 62 political statements, and then the model is evaluated to identify whether the model agrees or not to the statement. In fact, there are five different levels of agreement which have been evaluated: strongly disagrees, disagree, agree, strongly agree, or neutral, right? So that's that. And then the models that have been evaluated include both encoder-only models and language generation models. So for encoder-only models, the way these have been evaluated is to essentially come up with a prompt of this kind: please respond to the following statement. And the statement then could be any of those 62 political statements. And then the other part of the input is I mask with this statement. So this mask thing has to be filled in, and based on whatever is predicted, the embedding that is predicted for this mask token, similarity is computed with other words which are either which belong to a dictionary for each of these different classes. Okay. The way language generation models are evaluated is using this prompt: please respond to the following statement. And then there's the statement and then your response. So whatever is the output response, a stance detector is trained on the output of these models, which help classify the stance into any of these different classes. And then a combination of that is what you see here. So after these outputs have been evaluated, the overall output is sort of scaled on a scale of -10 to 10. So all these various classes or levels of agreement are sort of finally mapped into two parts: the social axis part and the economic axis part, both on a scale of -10 to 10. Right? And that is how they are plotted here. So what do you see on this chart? So you see on this chart, first of all, several different models which have been plotted here, both encoder only and language generation models. And you also see different colors. So each color sort of corresponds to a model family. So for example, there's BERT base and BERT large, but there's also Roberta base and Roberta large, and there's distal BERT as well. All of these basically are BERT based models in some way. Similarly, there's a family of GPT-3 based models, and then there's a family of BART based models, and so on. So there are different language model families that you see here. Right? So what can you observe here? So one thing that you can clearly observe is that pre-trained language models exhibit stronger bias towards social issues compared to economic ones. So as you see on the social axis, the spread is much larger. On the economic axis, the spread is not that large. Okay, so that's the first thing to see. The second thing that you see is that if you look at BERT variants of language models, they are more socially conservative or authoritarian, compared to GPT model variants. So you see GPT model variants sort of lie here, while BERT model variants that you see lie at the top above the, on the positive side of the y-axis, right? So that's the observation on the social axis part. And the observation, they tried to explain this observation. So if you look at BERT variants, they've been primarily trained using books data, which are typically older books, while the GPT kind of models have been trained on more recent data. And the idea is that, or the hunch is that modern web texts tend to be more liberal than older books texts, and therefore you see BERT variants to be more conservative, while GPT variants to be more liberal in nature. Right. So this kind of phenomena also can be explained and or looked at up in detail when you try to compare, in fact, models in the GPT family themselves: GPT-2, GPT-3 Ada, and GPT-3 Da Vinci. Right, and what you see here is that as you go to later models, you do observe well, you observe variations. You do observe variations. Some of them are more authoritarian, while some of them are more libertarian. So, for example, if you look at this one, mothers may have careers, but their first duty is to be homemakers. Now, GPT-3 Da Vinci seems to be, very awesomely agreeing to this. So I agree with this statement and so on. While if you look at the output from GPT-2, you observe that, the model does not really agree with the statement, but sort of provides a counter argument that there's a great diversity of women entrepreneurs rather than, considering homemaker being the first duty. Okay. Now, the next question is what happens if you pre-train models with partisan corpora? So, of course, they have their own biases anyway, but if you further pre-train them with partisan corpora, what happens? And for this experiment, what these guys did was to essentially come up with 6 different corpora. So 6 different partisan corpora. So basically saying biased corpora, right? Now, there are 3 different types of political leaning and 2 different types of domains. So news versus social media domains. And that is what gives them 6 different types of partisan corpora. News left, news center, news right, and social media left, social media center, and social media right. Okay. So for the news part, they basically use the politics data set, which has already been divided into left-leaning, right-leaning, and center. For social media, they actually depend on subreddit lists, which have been also labeled as left-leaning and right-leaning. Now, further, using these 6 different corpora, they further pre-train the Roberta and GPT-2 models. Okay. So remember, the Roberta or the BERT kind of models are more authoritarian in nature, and GPT models are more liberal in nature in that senses. Okay. So the idea is that, now what is shown on these charts is, of course, the x and the y-axis, the meaning remains the same, but what is shown is what happens when you try to, pre-train with left-oriented, left-leaning corpora or right-leaning corpora, versus what happens when you, pre-train using Reddit corpora versus news kind of corpora. Okay. So what do you observe? You do have some observations, and the observations are as follows. Uh, that language models do acquire political biases from pre-training corpora. So if you look at it, right, I mean, there are political biases which basically do reflect. There is a spread which reflects in these special pre-training that you do. Left-leaning corpora generally result in a left or liberal shift on the political compass, while right-leaning corpora result into right shift. So all the red arrows seem to be going to the right, right? Red arrows seem to be going to the right. Blue arrows seem to be going to the left. So left ones basically lead to more left-leaning models, while right ones lead to more right-leaning models. That's sort of obvious and expected as well, right? But it's dangerous to think about it that way, right? So pre-training corpus can actually decide the political leaning behavior of your pre-trained model. That's the most important takeaway, right? So most of the ideological shifts, however, interestingly, are relatively smaller. So suggesting that it is harder to alter the inherent bias which is present in these initial pre-trained models. So which is somewhat of a good news in that sense. Especially if you look at the biases, changes that happen in the GPT-2 model, they are relatively narrow and relatively rather controlled. Okay. Um, Now, the other thing to observe is that typically, if you look at the Roberta model specifically, and if you look at the left-leaning corpus, especially the Reddit corpus actually causes a lot of change here on the on this axis, on the y-axis, which is the social axis. So basically, making the Roberta model, which originally is essentially pretty authoritarian, move towards the liberal regime. Right. Now, the idea here is as follows, or rather, the other way of saying this is as follows. If you look at Reddit kind of corpora, right? Look at Reddit kind of corpora, whether you see it here or you see there, or you see here as well. So Reddit kind of corpora essentially, which is basically user generated text on social media, have a greater influence on the social values of large language models, while news media have a greater influence on the economic values. Right. So if you and the idea is that, well, news media often reports on economic issues, so therefore it's sort of expected that news media leads to more implications on economic access, while political discussions on social media tend to focus more on controversial culture wars and social issues, which basically means that yes, the political discussions, social media discussions lead to important implications on the social axis, right? So the next question that they try to answer is how do politically biased pre-trained language models perform on hate speech detection and misinformation detection? So they have experimented already with pre-trained models. They take those pre-trained models, specifically they take the Roberta model, which is neutrally pre-trained, and also they take 4 further pre-trained Roberta partisan models. So these are the 4 further pre-trained Roberta partisan models. Okay, out of the 6 that we just looked at, because you ignore the center one, so you're left with left and right alignment or social media or news-based pre-training, right? So they take those and they essentially fine-tune on hate speech detection and misinformation detection corpus, and then they try to evaluate how does the overall performance vary across these across the neutral model, across the original Roberta model versus the partisan Roberta models. Okay. So here are some of the results. And even before we look at those results, the main takeaway is that the overall performance remains consistent across such politically biased language models. So all of those results I've not shown them on this slide, but their observation is that overall, if you look at hate speech detection, misinformation detection accuracies, they do not change much across the original Roberta model or politically biased models, which is essentially good news. However, if you look at specific behaviors for specific subclasses, then you do observe significantly different behaviors. Okay, so what you see here is hate speech detection results, and what you see here is misinformation results. And on the as columns, what you see here is different classes, different victim classes. So Black, Muslim, LGBTQ plus, and then Jews, Asian, Latinx, women, Christian, men, white, and so on, right? So these are also divided into 2 kinds of classes. So if you look at, in more detail, so Christian men and white are more like identity classes, while the others essentially, if you look at others, they basically widely regarded minority groups in that senses. Right? If you look at the other kind of task, misinformation task, again, you have different classes. And in this case, the different classes are basically news media groups. So Huffington Post or New York Times or, CNN, the news agency, right? NPR, NPR, right? And then The Guardian, Fox News, you have Washington Examiner, you have Breitbart, you have Washington Times, and you also have National Review. So different news agencies or newspapers, right? So, and what you observe on these things is that as you see, the performance sort of widely differs across these different identity groups. In fact, what you observe, if you look at these left models, they perform better in these kinds of situations. So you see the performance is really good here. So the dark yellow color sort of, or rather the orangish color tells you higher performance. The blue color sort of dark blue color tells you low performance. So you see left models exhibit better performance towards hate speech directed at widely regarded minority groups, right? While if you look at rightly aligned models or these models with right inclinations, you basically observe them doing better in this part of the matrix, which is basically about identity groups such as men or white, right? Now, if you look at misinformation tasks, you observe that left models are more stringent with misinformation from left-leaning group, so from right-leaning media, right? So basically, if you look at left-leaning models, they are more stringent towards misinformation from right-leaning media, but are less sensitive to misinformation from left-leaning sources like CNN and NYT. So specifically, if you look at these, they perform really poor here, right? While if you look at right ones, basically you observe that they are really, less, they're sort of less stringent towards right-leaning media, right? And more stringent towards the left-leaning media. Left or right inclinations for these various newspapers are also labeled here, right? So essentially the left one, this part is essentially about left-leaning newspapers, while this part is about right-leaning newspapers. Okay. So in short, yes, I mean, pre-trained language models do exhibit different political biases. And when you fine tune them specifically for hate speech detection or misinformation detection, well, those biases do exhibit when you look at subclass level behaviors. But the good news is that overall performance across these downstream tasks remains consistent. Now, this can have implications. So the subclass differences can have implications. For example, if a content moderation model, a hate speech model, is built for detecting hate speech, and if it is more sensitive to offensive content directed at men than women, then it can result in women being exposed to more toxic content. Right. Similarly, if a misinformation detection model is excessively sensitive to one side of a story and detects misinformation from that side more frequently, it can clearly create a skewed representation of the overall situation. Right. So how do you handle such issues in pre-trained and fine-tuned language models on specific tasks like hate speech and misinformation detection? Well, the authors propose two strategies to mitigate the impact. One is partisan ensemble. So essentially, you create these partisan-specific models, and then to be able to include diversity of opinions across these models, you create an ensemble. Now, of course, this basically means that at inference time, you have to keep multiple models ready, and you have to inference across all of those models. Right. The other way of dealing with this is to build models which are tailored to specific scenarios. Now, what is observed is, of course, on the previous slide, I talked about this observation that language models are more sensitive towards hate speech and misinformation from political perspectives that differ from their own. Left-leaning ones were really good at figuring out misinformation from the right-leaning media, right? So therefore, it could be a good idea to build specific models tailored to these specific scenarios. When you're dealing with right-leaning media, use models which have been pre-trained and fine-tuned on pre-trained specifically on left kind of sources, okay, and vice versa. Okay, so that's it. That's about this video. Hope you liked the video. Thank you for watching. This was one of the best papers at ACL 2023. So this hopefully was interesting to you. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.